We've all been stuck in traffic, right? It's a pain. Now imagine a world without bridges or flyovers. Getting around would be a nightmare. Bridges and flyovers are like the veins and arteries of a city, keeping things moving. They connect communities, cut down commute times, and make sure goods and services flow smoothly. Without them, our lives would be a whole lot more complicated. Think about emergency vehicles. They need to get to where they're needed fast. Bridges and flyovers provide those crucial shortcuts, saving precious minutes when it really counts. Plus, they reduce congestion on regular roads, making life easier for everyone. But it's not just about convenience. These structures are symbols of human ingenuity. They represent our ability to overcome obstacles and connect with each other. And let's be honest, a well-designed bridge or flyover can be a thing of beauty, adding to the character of a city. So, next time you're zipping across a bridge or soaring over traffic on a flyover, take a minute to appreciate these engineering marvels. They're more than just concrete and steel. They're lifelines that keep our world connected.
Building a bridge is no walk in the park. It's a massive undertaking that requires meticulous planning, serious engineering chops, and a whole lot of hard work. Let's break down the process, step by step. First up, you need a plan. Engineers and architects work together to design the bridge, taking into account things like traffic volume, the surrounding environment, and the type of soil it'll be built on. This stage involves a ton of calculations and computer modeling to make sure the bridge can handle the load.
Once the design gets the green light, it's time to gather materials. We're talking massive amounts of steel, concrete, and rebar, all carefully selected for strength and durability. Then comes the construction phase. This is where things get really impressive. Giant cranes lift and place huge sections of the bridge, while skilled workers weld, bolt, and pour concrete with incredible precision. It's a carefully choreographed dance of heavy machinery and human expertise. The whole process can take years, depending on the size and complexity of the bridge.
Bridges and flyovers aren't just impressive feats of engineering, they're economic powerhouses. Building them creates thousands of jobs, from construction workers and engineers to truck drivers and material suppliers. And once they're up and running, these structures keep the economic engine humming. They improve transportation networks, making it easier and faster to move goods and services. This boosts efficiency, lowers transportation costs, and can attract new businesses to the area. Improved accessibility also means increased tourism. People are more likely to visit destinations that are easy to get to, and iconic bridges often become tourist attractions in their own right. Think about the Golden Gate Bridge or the Brooklyn Bridge. They're not just landmarks, they're economic drivers for their cities. But it's not just about the direct economic benefits. Bridges and flyovers can also improve quality of life. They reduce commute times, giving people more time with their families and reducing stress levels. They can also connect communities that were previously isolated, fostering social and economic opportunities.
Section 4, Building Dreams, Constructing Your 3-Bedroom Haven. Building a 3-bedroom apartment is like putting together a giant Lego set, only with a lot more sweat and maybe a few more choice words. It all starts with a solid foundation, which will require about 60 cubic meters of concrete. That's roughly 2,100 cubic feet, enough to fill a small swimming pool. Next, you'll need around 40,000 bricks for the walls, along with mortar to hold them together. And don't forget the roof. You'll need sturdy timber beams, roofing sheets, and tiles. All in all, you're looking at about 15 tons of steel for reinforcement and structural support. Now let's talk about the messy stuff. Sand. You'll need a mountain of it, about 50 cubic meters for plastering, mortar, and concrete. And to bind it all together, you'll need around 2,000 bags of cement. That's a lot of heavy lifting. Of course, these are just rough estimates. The exact quantities will depend on the size of your apartment, the design, and the materials you choose.
Section 5, Paved with Purpose roads built to last. A road that lasts 50 years? That's not magic, that's good old-fashioned engineering. Building a road for the long haul requires tough materials and a solid understanding of how to layer them for maximum durability. It all starts with a strong foundation. This usually involves compacting the soil and laying down a layer of crushed stone or gravel. This base layer provides drainage and helps distribute the weight of vehicles evenly. Next comes the subbase, typically made of crushed stone or gravel mixed with a binding agent. This layer provides further support and helps prevent the road from cracking under pressure. On top of that goes the base layer, which is usually a mixture of asphalt or concrete. This layer provides a smooth, durable surface for vehicles to drive on. Finally, the top layer, or wearing course, is applied. This layer is designed to withstand the wear and tear of traffic and weather. It's typically made of high-quality asphalt or concrete, and may include additives to improve skid resistance and durability. Section 6. Conquering the depths, pillars in the water. Building underwater is no easy feat. It's like constructing a skyscraper while blindfolded and standing in a swimming pool. But engineers have developed some ingenious techniques to overcome these challenges. One common method is to use cofferdams. Imagine a giant watertight box built around the area where you want to build your pillar. That's a cofferdam. Once it's in place, pumps remove the water, creating a dry work environment. Another method is to use caissons. These are large, hollow structures that are sunk into the water and then filled with concrete. Think of them like giant, upside-down buckets that form the foundation of the pillar. For deeper water, engineers might use specialized barges or platforms equipped with cranes and other heavy machinery. These platforms provide a stable work surface for driving piles, pouring concrete, and assembling prefabricated sections of the pillar.